mates together.
ध्रुवेश और हम लोग कॉम्पिटिटर हैं भैया।
अरे सर
जब 11 साल पहले मिले थे तो थे, अब नहीं।
कॉम्पिटिटर होते तो कई बार मिले थे ना।
नहीं,
Can you just present your screen at least, Louis, by the time?
We are complimenting each other, sir. The expertise what we have.
Present your screen.
We were bidding. Good, Dhruvesh Shah. Good to see you, boss. After 9 years.
Yes, sir. We are complimenting each other, sir. Expertise you have, I don't have, and what I do something good, like I can be extended to you, sir.
मेरे पास क्या है मुझे नहीं मालूम, मैं सर बताऊंगा आपको बाद में। Good, Professor Jyoti Busari ma'am, to recall old friends. मतलब बहुत साल के बाद, almost 9 years, मतलब सर को देख के अच्छा लगा।
मेरा तो ठीक है। पिल्ले साहब से कब मिले थे आप?
पिल्ले साहब को तो मैंने उस दिन फोन भी किया। पिल्ले साहब ने मेरे को पता नहीं गुरुजी हूँ कि नहीं रजिस्टर्ड।
When did you call?
अभी मैं तारीख नहीं बताऊंगा, मेरे को मालूम है ये सवाल आएगा, मतलब मेरे को मालूम था ये सवाल आएगा, तो मैंने इसलिए तारीख के बाद ऑलमोस्ट 9 इयर्स देख के अच्छा लगा।
I don't have your number.
पिल्ले साहब को तो मैंने उस दिन फोन भी किया। पिल्ले साहब ने मेरे को पता नहीं गुरुजी हूँ कि नहीं रजिस्टर्ड।
When did you call?
When I have called on,
He called the next day when I called you, sir.
Okay. Maybe can you give, because I don't have your number, maybe Gopal. Yeah. Is this you? Hello.
Ruhi, can you just present your screen? Let me just check whether it is properly visible or not. मतलब कहीं कहीं lag हो जाता है तो I just want to check that.
Who, me?
No, Ruhi.
Okay.
Because now we'll go live in a minute or so, na? So they kindly.
में जाएंगे लाइव।
Yeah.
और स्वप्निल साहब क्या हाल चाल है?
बढ़िया।
प्रेसिडेंट सर अपने डीजी साहब आए? विनय गुप्ता सर।
Yes.
ये सब हम लोग ओल्ड स्कूल वाले हैं सर।
Oh, I see. Very good.
ये ज्योति मैम का धन्यवाद, प्रोफेसर ज्योति मैम का।
अरे धन्यवाद क्या, एक्चुअली जैसे बताया ना, लास्ट जब हमने IIB पुणे सेंटर से ये प्रोग्राम किया था, तो आई हैड कॉल्ड ध्रुवेश एट दैट टाइम एंड हिज लेक्चर वाज द मोस्ट व्हाट यू कैन अपलोडेड बाय एवरीबॉडी।
Very good.
Yeah.
So we have made the right choice today.
Yes, very good. He is very good. The subject command is very good.
Yeah.
That is the best part. कुछ गुरुजी आज नया कुछ सिखाना आज।
बिल्कुल सर, बिल्कुल।
I can see Engineer Hegde also.
Yes.
Good afternoon. Good evening.
Good evening. So Hegde sir, on a different note, I have added some ground anchors.
Very good. Thank you very much. That's very nice. But the only thing is, we'll have to mobilize people. Let us see.
So let's go public now. What's her name, Ruhi or Deepika?
Yeah, it's
5:36.
okay.
I would suggest, Professor Jyoti, I would suggest that if you are putting this on YouTube or something, maybe we should stop recording and restart.
Right.
Yeah. Because
Ruhi, can we do that as suggested by?
Yes. Yeah, that's correct. You know, Ruhi and Deepika, the recording should begin at this time when we really do the broadcast.
Stop it and restart.
Yeah, earlier part is, all leisure. We need not, we should not rather.
We should not.
So once we broadcast, only then things start getting live on YouTube.
Okay. That is what. That's what we need.
So
Fine.
Dr. Pillai, what's happening on the epoxy bath?
Sorry, who are you talking to?
Dr. Pillai,
Yes,
what's
sir.
happening on the epoxy coated bars?
We don't want them, sir.
No, there is a fight going on, Vinay.
I know. Yeah, you're telling others.
What is
Yeah,
it?
actually, it's what to do. I don't know. We need to make sure the material we use are of good quality. So Sir, can we restart the recording, Professor Jyoti?
Yeah, I have just asked Ruhi to do that. Ruhi,
I'm not seeing it
he
getting
is having all the controls.
Yes, ma'am. Recording is on.
No, we need to stop and restart.
No. What he has suggested that you first stop the recording and then again restart. So whatever part lapsed till now, that can be removed from, means it will not be available. That is what he's saying.
Now
recording should start
So,
from the
Swapnil,
point when we begin the program.
As of now, I do not see Mr. Devte. In case he doesn't join at the right time, in that case, you can decide on me.
Yes. That's what I would take the call. Yes.
Yeah.
Ruhi, can we broadcast now? I think it's time now.
Yes,
Sure,
ma'am.
already
Already done.
Okay. Yeah. Participants have started. Can we start, Joshi sir? Swapnil?
Yeah, we can just a minute.
Yeah.
You're audible.
Yeah, we'll wait for a minute just to see furthermore, and at 40 we can just start.
Sure,
so Deepika, you can start at in a 1 minute's time. Yeah, Ruhi. I think we can start now, Ruhi.
Okay. Good evening, everyone. We welcome you all for our special lecture 16 series. Today we have with us Engineer Durvesh Shah. He will be speaking on post-tension tendons and bridge structures, evaluation and protection. I would like to introduce our host for the day, Engineer Swapnil Joshi. Engineer Swapnil Joshi, an intellect who possesses bachelor's in civil engineering and double post graduation from United Kingdom and NICMAR, with
Ruhi, your voice is
I think Ruhi got disconnected, so I'll continue with the introduction of our Secretary, Honorable
State Power Project TENDONS, etc. With successful implementation of digitalized integrated approach and his expertise in project planning, BIM and technologies, he is able to deliver the client's goal successfully. Swapnil has been rewarded by Indian Institution of Bridge Engineers from the hands of Nitin Gadkari in 2014. With this introduction, I request Engineer Swapnil Joshi to take over the session. Thank you.
Thank you, Ruhi. Thank you for the quick introduction. Let me officially welcome all of you for today's lecture series number 16, post-tension tendons in bridge structures, evaluation and protection by Engineer Shah. Let me, before going to the introduction of other part, let me introduce our main two pillars of the organization, Director General of IIB and President of IIB. our Director General Engineer Deepak G. Divte is a graduate in civil engineering from College of Engineering, Pune in 1974. Through 1975 UPSC exam, he has joined. Just a minute. Yeah, he has joined Indian Railways Service for Engineering as Class 1 officer and retired as Principal Chief Engineer of Indian Railways in 2011. During his service, he worked on many important railway infrastructure projects, occupied important posts of Principal Chief Engineer on Northeastern and Southwest Railway. He was Director or Board Member on Konkan Railway Corporation, Chief Engineer of Konkan Railway, Chief Project Manager for Tunnels of Mumbai-Pune Expressway, Project Director of Katra to Luli portion of Udhampur, Baramulla, J&K Railway Project. Recently, he was the one who was working as a CGM on fully underground metro line number 3, which is around 33.5 kilometer in Mumbai. So I think DG sir is not yet not able to join at the particular moment. So I'll just go on, and once he is back, he'll say a few words about it. So Ruby, can you go to the next slide, please? So our another important pillar, and the one who encourages all our team members to go or achieve furthermore heights for IIB is our President Engineer Vinay Gupta, Director and CEO of Tandon Consultants Private Limited. So he's a civil engineer from BITS Pilani, 1983 batch. His specialization ranges from bridges, flyovers, underground and elevated metro structures, precast buildings, 275-meter tall chimneys, etc. He is an active member of various board committees of BIS and IRC. His contributions include preparation of IRC SP 65, IRC SP 71, etc. He is a recipient of several awards from IBC and UKI ERI. He has been lecturing as a guest faculty on various bodies and institutions like IIHE, CRRI, CIDC, etc. Engineer Gupta is All India President for ICI and our institution, Indian Institution of Bridge Engineering. So with this quick introduction, may I invite our President to say a few words about IIB, and then I can go ahead. Vinay sir, over to you.
Thank you, Swapnil. I hope I am audible.
Yes.
Okay, so a very good evening to everybody that you have taken out your time, joined us, and encouraged us, I must say. We are having, of course, a lecture on a very important topic, which you will all hear from Mr. Shah. But before that, a few facts about IIBE. It was established in 1989 by engineer MC Bhide, who retired from railways as chief engineer. And he took the member strength from 89 till about recently, till when he was alive, to almost 7,000 members. And we are continuing it further. His dream was to disseminate knowledge in the field of bridges, and we are all trying to continue with his dream. He also wanted to have an office of IIB's own. So also we are purchasing an office here. Over this tenure of about how many now, 89 till 31 years, there have been, in the peak, there have been about 38 local centers of IIB, apart from the head office is in Mumbai. And there are some 29,000 pages of technical literature that has been put online. IIB has a full-fledged website. It has a payment portal, and all these upgradations to the IIB have taken place. Apart from that, some of the centers may not be active, but one by one, centers are being reactivated. Now, for example, recently, in fact, today only, I received a request from Chennai Center, Dr. Rajgopalan. He mentioned that he was honorary secretary, of course, and later on it was picked up by Mr. Srinivasan or Dr. Srinivasan, not Srinivas, sorry. And now we have to reactivate with another honorary secretary, local chairman. Recently, we reactivated Hyderabad Center. So likewise, every center which has been in existence must come back in existence. That is the basic forte. The major events of IIB that we have now, one is that we are planning to have awards. Towards the end of this year, we'll have an award function. Apart from that, we have one major event, which is mega event of IIB called Bridge Year. We had Bridge 2018 in Lucknow. We had Bridge 2019 in Patna. We had Bridge 2020 all over India online. And now we will have Bridge 2021. Let's see where we organize. We are just deciding about it. And of course, awards function. So, and apart from that, we just picked up this good trend and new hobby that we started having online lecture series, special lecture series, let's call it. And today we have 16th one of that. And I'm very thankful to the speakers, to the panelists, to the moderator. We have a very enthusiastic team here. And my special thanks go to my two main pillars, that is the Honorary Secretary, Engineer Swapnil Joshi and Dr. Gopal Rai. And the two backbones are Engineer Lawyer Ruhi and Engineer Deepika Singh, who are holding the post. And we, of course, come in just to show our faces and speak out a few words. That is Mr. Devte and me, both. But anyway, everybody is required, it's a complete team that is needed. But friends, all your support is necessary because such knowledge dissemination events are only events when you are all there. And how can you all be there? Please become members. Once you become members, we have a better encouragement to ourselves. We feel encouraged when we have more members. It's so obvious. We feel encouraged when we see more of you in the conferences like this. We feel encouraged when we hear questions from you that you are taking interest, asking questions, and we're giving opportunity, or you're giving opportunity to the speaker, to the panelist, to the moderator, and to me and to everybody to answer. That's the whole thing, you know. It's like shares. When one share rises, other share rises, every share rises. When shares fall, they just fall. So when we are all there, we are there. When we're not there, nobody's there. There's no event. So it's all of us who make this event. And please come and join every time, every now and then that we have this event, almost 2 to 3 times a month. And I hope we continue this forever. Thank you so much.
Thank you very much, sir. Ruhi, can you just present the screen, please?
Yeah.
Yeah. So now let me. Yeah, Gopal.
Yeah, I think to add to Vinay Gupta sir, actually we should ask because we can see from last 16 lectures, repetitive the audience are there. If they want to listen some subject in the questionnaire, they can also put some subjects so that we can look for speakers on that direction out. So we'll request a question hour. They should put their view on that this subject they want to listen. So that's so to the participant. Thank you, Swapnil.
Yeah. Thanks, Gopal. Good suggestion. So I'll request all the participants to put up your, interest subject of your interest in the question answer box so that we can take care of it in the coming lecture series. Okay. So now let me go ahead with the quick introduction of my colleague in the organization and a doctorate dynamic person, Dr. Gopal Rai. He's a chief executive officer of Dren Group of Company, specialized in repairs and rehabilitation, done his PhD from IIT Bombay. His phenomenal level of powers has enabled him to be associated with several prestigious projects, including the Apsara Reactor, VARC, Mumbai Airport Bridge Strengthening of Material, which is being presented in various national as well as international forums, ESIC Hospital, JNPT ROB Bridge, and many more. He is Honorary Secretary of our institution, Indian Institution of Bridge Engineers, General Secretary of Association of Structural Rehabilitation and Retrofitting, Committee Member of ISAC, Mumbai Center, BIS, and ACI. He has delivered more than 680 presentations nationwide and 27 presentations internationally. He was also a keynote speaker and author in 4 international conferences and more than 10 national conferences. Presented more than 100 number of research papers, which is being published in various journals. Dr. Gopal Rai got awarded for 50 Manufacturing Innovative Leaders at World Innovative Congress Award 2019 and also in Dubai for 40 Most Influential Leaders Under 40 Years 2017-18 by Asia One, and many more to come as well. So with this quick introduction, I'll go ahead. So Gopal is again a good colleague to work on, that keep on pushing the whole team for new things to be updated. And we are blessed to have a stalwarts in our committee, I'll not name everyone, so you know almost all the members. Busari madam is already there. Hegde sahab already is there. Subbarao sahab is already there. Engineer Atul Bhobe, Dr. Vishal Thomre, and Dr. Surya Prakash, and Avinash Manjarkar. So we are blessed to have a good, the stalwarts in the executive committee. So, thanks everyone. Now let's go to next slide, please, Ruhi. So let me introduce our today's moderator, Dr. Jyoti Busari, Professor Civil Engineering, Sinhagad College of Engineering, Pune. A professor at she's completed her post graduation in structural engineering from MS University, Baroda, PhD from Shivaji University, Maharashtra. Has 27 years of rich experience in teaching. She's a member of Board of Studies for Rail Technology at the Faculty of Science and Technology, Savitribai Phule, Pune University. Chairman of various subjects related to structural engineering at UG and PG level at Pune University. Has received several research grants from Pune University with the research work mainly focusing in the domain of characterization of special concretes and finite elements, analysis of structures. 15 research publications in various reputed journals on her name. Co-authored 2 textbooks, Structural Mechanics 2 for third year students and Mechanics of Structures for second year students of civil engineering. This quick introduction of our today's moderator, I would request Dr. Jyoti Busari ma'am to take over the forum and conduct the further session. Over to you, ma'am.
Thank you, Swapnil.
Thanks. Yeah, ma'am.
Yeah, thank you, Swapnil. So I'm the moderator for the today's session. Just begin with, actually it will be nearly, let's say nearly 100 years close now when the Freseniate, it had proposed the use of post-tension concrete in nearly 1928. Though the first structure using the post-tension technique came into existence in about, say, 1940s. But now in India, as well as in the worldwide, bonded post-tension tendons are extensively adopted for the construction techniques of various structures, as well as I will specially mention that is mostly for the bridges. Now, if you're having the well-grouted post-tension tendon without any voids or without any grout defect, then that would be nearly a very ideal condition. And in this scenario, evaluating the in situ conditions of the grouted post-tension tendons in a sealed duct can be really challenging. So evaluating the risk of the corrosion and the corrosion activity going on in the tendons, once the grout detect or any void is detected, that is a further challenge. So what can be done to mitigate this corrosion activity and thereby extend the life of the structure? That is, I think, the crux of the webinar today. Today's speaker, Dhruvesh Shah, as well as our panelist, Dr. Pillai, both are expert in this corrosion technology. And Dhruvesh will be discussing about the non-destructive methods of evaluating the grout condition, detecting the voids, as well as the soft grout within the sealed ducts. And as well as he will be covering, I think, the history and the development of an innovative post-tension impregnation process that can be effectively protect the tendon from the further corrosion. So for this particular the panelist we have invited is Dr. Radhakrishna G. Pillai. So can I have the next slide? Yeah. So Dr. Radhakrishna G. Pillai is an associate professor in the Department of Civil Engineering at IIT Madras. He has earned his B degree in civil engineering from MN Regional Engineering College, which is now called as MNNIT, Allahabad. Then he earned the MS and PhD in civil engineering at Texas A&M University, USA, and got passionate to combat the corrosion of steel in reinforced and pre-stressed concrete structure. And that's why he is here as a panelist today for the rightly selected topic of corrosion in post-tension tendons. In September 2010, he joined IIT Madras and he has been teaching in the areas of construction materials, concrete technology, and repair of concrete structures, and has engaged himself in the development and the other activities of construction material research laboratory. He is running various research projects which are again focused on the steel corrosion and its impact on the service life of concrete structures. In particularly, he focuses on developing the corrosion test methods, database, and the tool for practicing engineer to promote service life-based design of concrete structures. Recently, he has been extending his research to cathodic protection and extension of residual service life of concrete structures. And he has co-authored more than 50 journal papers and many conference papers. So, well, I welcome you, sir, as a panelist for this session. Can I have the next slide, please?
Thank you.
Yeah. The speaker for today's presentation is Dhruvesh Shah. Mr. Dhruvesh Shah, he has done ME Structural Engineering from MS University of Vadodara in 1995. He is involved again with the health study and corrosion assessment and execution of various civil engineering projects in the specialized field of corrosion mitigation, repair, and strengthening of RCC structures in diversified industries since nearly 25 years, not only in India, but UAE, North America also. He is one of the faculty in CII's Corrosion Manager course for developing corrosion managers, and also is a board member of CII's Corrosion Management Committee. He had been author and co-author writing technical papers on corrosion mitigation of RCC structures and has delivered various technical presentation on the forum of FICCI, NACE, Corcon, Redicon, Nijis SZ at IIT Madras, IIB, and various NITs and IITs as well, and private university on the same subject, that is a corrosion. Currently, he is the head India business for Vector Corrosion Technologies Canada, and he's consultant also for corrosion mitigation and strengthening of RCC structure. So Dhruvesh, I welcome you and I invite you to begin with your presentation on post-tension tendons in bridges structures, evaluation and protection.
Thank you, Jyoti, for the introduction. And thank you also for briefing the crux of the subject what we are talking. Normally, I am a RCC cathodic protection guy. I deal with a lot of like durable solution to RCC structure. But in recently, like a few, maybe a couple of years or more rigorously in few months, I come across various problems with the solution for bridges. Like I came across that there was an many of the states are going on for the health study of various bridges, and that lot of issues are there with the post-tension tendons. It may be grouted one, or it may be a like bonded or unbonded. The unbonded has a different issue and different solution. I am focusing more on the bonded one here. I don't know if time permits, I can speak something about the unbonded tendon also in between. So with that, and thank you, Dr. Krishna Pillai, for becoming a panelist, and it's my pleasure that you are here. And thank you, IIB team, for managing and keeping this special lecture 16. Just brief about the vector corrosion technologies. We are world leader in corrosion mitigation solution for RCC structure. Our products are GalvaShield range of products with various sub-names. And we have office in Canada and a regional office in US, Canada, UK, and Latin America. A distributor network all over the world. I take care of India business, like main business development and technical supports. And we have a 2 distributor who can cater for the supply and special assistance at the site. One caters for the North India and maybe West and North, and TradeWinds from Chennai, like is Dr. Rajendran, High Tech, same one. They are catering about the South India and the eastern part of India. Vector is highly involved in advancement of technology within our industry through representation in industry organization, few names, international names. That's why when it comes to IIBE presentation, I proactively asked Jyoti to please arrange the lecture at the suitable time, and it's good that is happening now. What like today's lecture, photo might not be too much sophisticated, but it shows that like how you can evaluate and protect what is the process, how it can be done. My whole presentation will cover evaluating grout condition and detection of voids, soft grout using NDT method, little bit of history and development of post-tendon implication process, protection of segmental bridges and other post-tension structures. Like a nice looking bridge for which like it is mainly this type of bridges we see now and then in India also, which normally use post-tension tendons, like maybe 8 or 10 length of a bunch of bridges. But if we go for history, what Dr. Jyoti has uttered, that the Mr. Freycinet has proposed post-tensioning in 1928 and first PT bridge in France in 41, when it was used in Europe, and first PT bridge in US in 1951. Then it was like used in abandon, mainly because it's for the long span, it's very convenient and more value engineered, fast construction, it can be a good one, and sufficiently efficient long span bridge, as I says. And this is the first segmental bridge built in USA in 1973. And this is the current condition. And when our vector team at North America got able to see one of the duct, the grout was found well grouted PT tendon and no corrosion. Imagine 1973 grouted and it's still in good condition. But all bridges are not same. You have PT tendons in the bridges found like in this condition. These photos may be of external PT or some of the PT which are not of the bridge, but it gives you a glimpse of what happens. Like left-hand side photo, top one is having an voids and corrosion happening. The bottom one, left bottom one is where corrosion, you can see that white color thing. This is because of the chlorides and the tendons has broken. And the end cap has broken on the right top side. And the middle one photo is basically because of the segregation of the grout. We'll talk more about all these things. Mainly what happens issues in PT grout. What are the issues? Like whenever you have a post-tension grouts, like for the grouted tendons, there can be a voids and water. You can see this water coming out from the one of the PT tents, which is going here on the right hand side picture. This is because there can be incomplete filling of duct, grout leakage before hardening of the grout, and grout bleeding and evaporation, which may be up to 3 to 5% of total grout volume. This is like it is found if it is cement water grout, this percentage could be there. But I had come across in India where the percentage of voids are even far more than this. And when free water within the duct, fridge thaw in cold climate or in other conditions, then it creates further issues with the tendons. There can be a variation in grout property. While pumping the grout, like if you have excess water, there can be a segregation. And the bottom dense portion will have a more hardened grout than the top portion. There can be a variation in pH. There can be a variation in density, porosity, chemical composition. Various reasons are there, because of which you have different characteristics of grout. And if there is a moisture presence up to more than 5%, definitely it's going to be corrode. And there will be a corrosion maybe of the top tendons, maybe of the sheath, or maybe of the grout which are having a not more dense material at the top side if it is on the lower portion of the tendon. And this all reason accelerate the corrosion. You have chloride contamination. We come across various places, particularly in Mumbai or in Chennai or where the seawater is nearby, because grout are leastly concerned by people, and simple at the end of it, the job nearly to complete, a local labor or not semi-skilled also will be asked to mix cement and water and do a cement grouting. Although this is not a question process everywhere, but the water which has been used has hardly been tested. And if they found that it is having a lot of chloride contamination, then it's a disaster. We have come across many of the sites, at least 4 places where this thing has happened. And this chloride contamination grout, maybe because of contaminated mixing water, or the grout itself has a chloride contamination. So American Society has done one mock-up also to know how the grout behaves. A real-time mock-up has been done, and they found that the cement grout, like they developed a bleed test, Very immediately after grouting, they made a glass tube and for a meter length, and they poured the grout, and they found that grout which is just 4 hours won't be have any bleeding, but at the 24 hours you can see the top bleeding thing. So you can simply have your grout tested at your site only. You can have a tube like this, maybe of 3-inch dia, and place in tendons in it, and the end cap, and when you wait for 24 hours, you will find this bleed, and this is what is detrimental. This is very, very normal in case of a cement water grout. Second, apart from the void, this is the picture which is showing segregation, like defective grout. If the grout is having more amount of chlorides or sulfates, you can see the lower end is very dense, and the upper end is having a voids or maybe having a fully grouted, but the grout quality is such that segregation has happened, and the top portion of the grout is not able to protect the upper strands or upper surface of the rebar, or maybe the underneath of sheath from corrosion. And when there is if you check it, remember that normally we use in RCC that if the chloride content is less than 0.6 kg per m3, then it is safe, and sulfate content is less than 4%. But if your grout has less chloride content, but even high sulfates, then also it will aggravate the corrosion if there is a moisture because of presence of sulfate. There is one report, it's a huge report, I can share if somebody wants that. This was also surprising to me also, but sulfate along with chloride, it really increased the rate of corrosion in case of PT strands. You can see what is the quality of grout, like how it is on the right hand pictures. So if we have grouted tendons and issues with the void, segregations, or moisture or water remaining there because of the bleeding, how to test? You can have various methods, which I will take one by one, which includes visual inspection by opening, locating tendons by GPR, grout void detection, boroscoping, PT corrosion potential evaluation by moisture test pits, chloride and carbonation test, petrographic and half cell potential evaluation. Simple grout penetrating radar can locate your PT tendons. That we can use. You can locate, and you can even make a window at some places. You can break the concrete above it and drill a hole. Right hand side picture is entering a boroscope wire inside to see the things. You can use this impact echosonic ultrasonic evaluation method. It is developed by Vector itself, and we use an impact equipment or a probe which impact, and this four thing will take the readings, and it will what you can say sonic ultrasonic sounds will be received by this probe, and depend upon the frequency we can find out that whether the voids are there in the tendons or not. If there is a voids, then the frequency will be less. It's a different path. If there is a dense grout, then the frequency will be higher. So first you need to locate the location of the tendons, and you can use this impact echosonic ultrasonic evaluation method. Like you have 100 or say you can have 1 kilometer of total tendons, and you can evaluate localized step-up method, that these are the position where my voids are there in the PT strand. You can use this type of impact echosonic ultrasonic evaluation. This will definitely give you voids, soft grouts, and water if at all it is there. Like this is a small video which will show how it has been used. It's very looks very simple. The left hand side person is impacting, and the right hand side person is moving the probes, and readings has been taken in the equipment, and he moves along the line of the PT tendons. By this way, once we detect the voids, this is a small, like this particular bridge, small walkway bridge, we have detected the void, and then we cut open at that particular place, which shows that yes, there was a void inside the sheet. Once you detect where there are the voids, you come to know, you can simply make a small hole up to the sheet, and don't use your drill to puncture the sheet. You can just use a sharp thing or screwdriver and make a hole, hardly 4 mm hole, and then you can insert the boroscope probe inside that thing in the hole, and you can get a good view of the condition of the sheet inside. You can even have a video of what is the condition inside. This is how a typical sketch shows that how to make a hole and then plug it with maybe a right grout, or maybe you can use Hilti anchor resin grout to fill that hole back. And these are some photographs which shows that boroscopic results, like void and bottom corrosion on ducts and tendons, corrosion on duct and tendon, like duct is also corroding and tendons are also corroding. This is void in pier with bar instead of tendons, corrosion in the duct, like various, you can get all of the details once you can insert the boroscope. So you can identify the tendons, you can have an impact echo test to know the location of the voids, and then you can insert the boroscope and you can have pictures and know the condition what it is. Like I will show you some examples. Sunshine Skyway Bridge, Tampa. One of the other method which can be used is a very high intensity magnetic detection of broken strands. Like on the left hand side, you see that this is a very high powerful magnet with the two sides, and this is roll over the slab. And when roll over the slab and charged, you will have a right hand side. You can see the north and south pole things going on, coming and up back. So if there is a break or a break in the tandem, cut in the tandem, you can see a failure. There will be a change in the graph. So this is one of the way. It has its limitation, like all other methods have some limitations. So it has to be judiciously selected where to go with which type of the detection method. Now, this is what I had talked about the voids. Now, what is the relation from where the corrosion comes, or how can be the corrosion rate we can evaluate? In particularly tendons, PT tendons, grouted tendons, you can see that this corrosion, the corrosion rate and moisture, this is particularly for a standard temperature. If you had a variety of temperature throughout a year, there can be a waves like this thing, but the ultimate graph is like simple this way. For up to some percentage of moisture, you have a very low corrosion rate, but if the moisture content increases, then your corrosion rate shoots up, and that's why even though there is a very limited oxygen also, the corrosion will happen. So there is a very much correlation between the corrosion rate and the moisture, particularly in the grouted tendons. One of the evaluation method, how we know that where the moisture is there or not. Like we do evaluation, we had to name it as a PT corrosion evaluation method. Like we select a tendons, we can simple puncture at one place, and we can insert a port in port, and there is a flow meter and there is a dry gas supply. So we supply the dry gas, we measure what the gas going inside, and the other end, the output, the gas comes out, and then we measure the moisture content of that gas, and it will show us that what is the moisture level inside the PT tendons. Like as I said earlier, if there is a different percentage of moisture, and if the moisture is more than 0.7%, it is wet, and it is considered to be a highly corrosive condition. This is one of the bridge where we try to do the moisture test by passing the gas from other side. Like it was sealed and a small dry gas has been injected inside, and the sheath was opened up. And this is how, actually this is a video, I couldn't run it, I don't know why, there is some issue. So you can see this moisture and water is coming out. So we can visually see that really the moisture was coming out from the other end.
Dhruvesh, I think you can play that. There was a button at the bottom left, yeah.
It's not, it says Vinia don't found. I don't know where.
Okay.
No issue. Then we chart it at a particular with temperature and relative humidity, and categorize in 3 different part. Like if you have a temperature, say around Fahrenheit in terms of this, and your relative humidity found less, then you are in the safe thing. But if it is little bit high moist cable, then you are in a medium risk zone. But if your moisture content goes high and with the humidity, like moisture level maybe 0.7%, then it's a bad thing to happen to your corrosion is going to happen for your tendons, and it's a high risk zone. This is one of the, yeah.
Actually, if you could use that pointer, it will be clearer. That
sure. This is one of the places where I was there.
The bottom, you'll have the red color pointer, no? So yes, lesser.
Okay. This is a view of an Banana Anon Bridge in Virginia, where I was there, and I had been part of checking the evaluation and then PT implementation also. Here we are, like this is the port, this is the point where drill has been done, and then small pipe has been put and connected to know what is the moisture content, and dry gas has been injected from the other side, and we are measuring the flow and the moisture content. And at that particular bridge, we found that most of the location, you can see it is basically very high moisture content. And when we broke open, we found that the tendons are really corroding. So it's like it's directly related to the moisture content in the grout. The corrosion rate will increase, and low moisture content, corrosion rate will be the low. You can do drying. Like if there is this can be used for the unbonded tendon also. Like unbonded tendons, there is no grout, it's all void. But if there is a moisture, then it will definitely lead to corrosion. So in case of a grouted tendons or unbonded tendons, you can do drying of the duct. It is similar to what evaluation we can do. Here, you can have a duct puncture at any middle or at the end, depending upon the feasibility at the site. And then you can supply a handsome amount of dry gas supply, and then you can measure it, and you can go on pumping the dry gas supply until you get a desired level of moisture. It means it is pushing all the moisture out of the grout and the voids also. So you are making your entire tendon dry. It looks very simple, but it's a bit complicated. Complicated in the sense that this is the arrangement somebody has to do. You cannot use a simple cylinder or a nitrogen gas or a balloon gas for that you can use for evaluation. But when it comes to drying process, you need hell amount of dry gas to be pumped. So you need a plant which can produce a dry gas. You can have a compressed air compressor to produce gas, then dryer, and you need to see that the dew point of the gas is around minus 20 degree or minus 30 degree. So you have absolutely complete dry gas which need to be pumped, and can be pumped from one end, and you have to keep on monitoring for maybe days, weeks, or months also, because it depends upon how dense the grout is, how the voids is, what's the percentage of moisture content, because we want to push all the moisture and all the water from the tendons out. So that's the way we can do the PT drying process. This is the another location from where the moisture has been measured. You can do it manually. Here we are doing with a more sophisticated equipment. So it will measure everything, that how much moisture is there from each of the tendons. They are all connected, and we can have all record what is the moisture level. This is one slide I've kept in between the tendons. Like this is slides which shows that how to protect the end caps. Many of the time we found that the tendons are good, but end caps are corroding. Dr. Pillai sir would like to see this, will be happy to see this particular photo, because he is always having a question about how they close the end cap. The people might not do proper grouting, or might not do proper with simple plastic cap, or they might be corroding. So end caps are always susceptible to corrosion. They are most likely to have access to the water from the external side. So if you can break open the pour back concrete, and you can simply use a normal sacrificial anode tie to the strands, and then fill back with the concrete. So the concrete will act as electrolyte here, and then it will protect your end cap from corrosion. While this case cannot be 100% good for the strands, because you won't have a 100% electrolyte, and the space is constrained. Now, when you know that yes, there is voids, there is ongoing corrosion, it is detrimental to my structure, and I want to protect my structure from my strands from further corrosion. But obviously, I cannot reverse the corrosion thing, but we can still retard the corrosion rate, so that whatever rate is there to 100 times less corrosion rate. So definitely it will enhance my durable functional life of the strands. The corrosion protection process for grout PT tendons with voids or defective grout can be done with impregnation material, which is transported from inside strand for full length of the tendons. It may be a 20 meter or 100 meter. I had done a treatment for 80 meter long strands without any joints. And impregnating material reduces corrosion by coating exposed steel in the voids and also improving corrosion resistance of the grout, the area around the strands. This is how you can do impregnation. Like you can transport the material from either at the end of the tendons, like opening of the end cap. And if accessibility or feasibility is not there, you can decide to make a puncture or entry point from the center somewhere, in which case the impregnated grout will flow on both the side. It will depend upon the side condition. We have to decide. This is a particular tendon what we see, which has a 19 PT strands, and these 19 PT strands, each strand has a 7 wire. Like the center is a king wire, and they are surrounded by the 6 wire, which is this is a zoom photo of one strand what we had seen earlier. Like these are 19 strands, and this is one strand. You can see the voids in between, which are called the interstitial voids. And these are in microns. So we want to use these voids and these small gaps around the strand. You can imagine a 50 mm or 70 mm tendons having 19 strands and grouted one. And this whole 7 wires is hardly 2, 3, 4 millimeter. So gap could be in hardly microns. We want to inject material through this. I will show you this with one of the case study. This was first time done in Florida DOT, Jacksonville, Florida. Fortunately, there were the external tendons instead of they were having internal tendons, but to know how it performs, the work has been full scale work has been done on the external tendons. It has a PVC duct. What we did is we opened this plastic cap, we removed the grout which was there, which was covering the strands, and this was how it looks. Then we install a port and again close that end cap and then start pumping the impregnation grout. Then once we had started pumping, and then we went on to the another side, and we see that grout was coming from the lowest tendon and from the upper tendon. Like it has traveled up to 72 meter and it is coming out. Then we wait further, and we can see that it was coming and was almost, the photograph was taken at that time, it was almost coming from all the tendons except 2. We waited more, and then it was fully saturated. Then we pressurize it. We keep for purging for some time as per requirement, as per our design, and we see that all the tendons are being coated with this impregnation material. Right hand side picture shows that it is not impregnated. Then to confirm what has happened to it, we cut open at one place, and what we found that all the tendons are properly coated with this material. There was impregnation material covering all the tendons which it find the gaps. This is another photo which demonstrates that it was a PT contractor who was to do this thing, and he has kept one pipe here to know how it is flow, and then we pump from the one side, and I will just there's a video. You can see the grout is oozing out. Yeah. And then we tried it for the end. You can see how much amount of grout is coming out. Although this is a 20 meter of length, and it was coming with a more velocity. But even if it is an 80 meter of grout or 70 meter, then also the grout will come. Although the speed may be less, but definitely it can cover entire places, whatever voids it finds. So we do from the center at another places. We drill the hole, we fix the port, and this is sort of equipment what we use, which has a source of grout which is beneath, and then we pump the impregnation material, and we checked at the other end. You can see at the end cap portion all the cracks or whatever position where the grout is traveling. It is confirming that it has traveled all along the PT strands. This is the another end where there is a pore block, end block, that also got some from the anchorage end and the complete pore block. There was a gap, so the material is oozing out. And then we even tested for, there's a small video, however it might not be too much sophisticated, but it is the video which shows that if we pump from the center, how the grout comes. We had put the port at the middle, and then we observe for the grout to flow. But obviously as it is on top, so the top one will have a grout coming out. Then from the bottom, then we started plugging it with a special sophisticated plug. You can simply push it. It was designed as per the requirement, and we simply plugged one. So it was started coming on from the different ports, from the different ends, and then we plugged almost all the ports, and finally, if you will see, it will come out from the last downmost port from the other side also, which ensures that entire strands has been filled. It will also saturate the grout around the strand, so it will make it more corrosion resistance. So that way it's really working. We'll run it fast. Basically, it just shows the same thing, that it is plugging the things, and finally it will come from the another last this end also, so that everything has been filled. Then we do the performance validation. Like we had a strand which is having uncoated, untreated, and a strand which has been treated with impregnation material. We have a salt spray method, and we had gone under the salt spray condition, and then it found that after a period of time, we had a full report if somebody wants. This is just to show what has been done. And we found that the strands which is untreated were corroding, and there was nothing issue on the strands which are treated. And to have a quantitative analysis, one can go with a perfect concrete, create a condition wherein there is a grout and there is a proper strand, and you can use a galvanostatic or potentiostatic testing. If you are applying current, you can use a galvanostatic, or if you are throwing in voltage or potential, you can use a potentiostatic testing. You can connect your one end to the potential state, and the other end to the potential state will connect to the external the electrode, and there will be a portable electrode also. With this whole system, the test has been carried out, and it was found it normally gives you the result of corrosion current. It was found that with 2% of chloride concentration, the untreated sample, the corrosion current was too high. And for the treated sample, we could able to reduce the corrosion current on very low rate. So this shows that current was very less. It was protecting. There was very less corrosion. So definitely, average post tension PTI cable, it really works. And when we quantitative it, we can find that there is a 93.1% reduction. It doesn't mean that if it is a log percentage. If suppose I'm able to retard 93 times the corrosion rate. This is what I mean to say, if you can use for the impregnation sort of thing. This shows the Coulomb charge, Coulomb passed, where also we find that there was a lot of reduction in the current, corrosion current basically. So it can enhance the life of your PT strands, and it will live a longer life without corroding. Some authorities has used this, published a paper, interim report was there, wherein the control sample was having a lot of corrosion. And these are the photos from the report only. And when the treated sample was not having any sign of corrosion, it was working wonderfully. This is one more, case study I would like to show, wherein this highway bridge, which was built in 1995 and some spans. I don't want to go in much of an logistics, but the internal tender were located using GPR, voids were detected, concrete and sheath removal of tendon inspection. We did all the tests, corrosion potential, pH, sample taking, everything has been done. And in this case particularly, what you can see is we found the voids and the accessible tendon were accessible. So we cut open it. We cut open it and we found there was a lot of voids, which can be filled with the different grout. You can regrout the tendons. Yes, when you regrout the tendons, what will happen? There was a grout which was there lying since many years, and pH is different. It was an older thing, and when you regrout with the very good quality of grout, there will be a difference of potential around the new grout and the old grout. So there will be a sort of incipient anode formation. It has been found that wherever at the periphery, like at the junction between the old and the new grout, you will find that the top of the strand wires get started corroding. So in such type of case, when you have a voids and when you can see that there was two different grouts and the surface started corroding. When this picture shows you well, there was a void which was grouted, and then what you can do is simply put a flat anode here. This is how it has been connected. So there will not be any incipient anode formation, and you can protect entire tendons from corrosion. This is what it shows. This is how it can be used. Like you can simply put an anode. It's a flat special anode made for tendons, and you can then regrout and repaste all these things. So your void has been filled, and you can protect your tendons from corrosion. Another way of protecting it. Then you can seal and regrout it. So if I say for the summary, like PT tendons are susceptible to corrosion. Yes, it's not that it cannot corrode. Evaluation techniques are available to determine the cause, extent and location of the problem. And corrosion mitigation techniques are available to protect and extend the service life of PT tendons in existing structure. We can help you out for any of your project. Questions?
Yeah, thank you, Dhruvesh. I think for the questions, we'll be waiting. First of all, we will like to have the panel discussion, and then we will invite the questions from the participants. So you covered a lot in and covering all the aspects of evaluation and protection of the tendons. So I would now like to invite Dr. Radhakrishnan sir to put your expertise on this particular topic and comment on this particular total session that has taken place. Over to you,
thank you. Thank you, Professor Jyoti. Thank you, Dhruvesh, for a nice walkthrough with some of the eye-opening photographs. I think some of these photographs are really eye-openers for many of us. And one doubt, I know we have engineer Vinay Gupta, Gopal Rai, and then engineer Hegde, all that here. So the question is mainly to them, and also Dr. Harshavardhan. So when we will start doing these kind of inspections in Indian bridges? Because all the examples which Dhruvesh showed are from abroad, and in India we are not doing all these unless we reach a very late stage, like unless it is too late. So we are still on a corrective maintenance strategy and not preventive maintenance strategy. That is a bigger discussion which we need to have. So having technology is one, but we are still waiting for things to happen. And then that's one thing which I would like to extend the discussion on. Other thing is, again, I mean, it's again balling around that only. So it's a new topic for many of us. We have not seen many of the failures of many of the collapse of post-tension system, but definitely, I would like to add here, when I came, when I started working in IIT, in fact, my PhD was on grouting and post-tension bridges and looking at reliability of structural reliability of post-tension bridges. We had example from San Antonio, Texas, and that's what we looked at. So when I came here, I saw this metro construction going on everywhere, and I found that the grout which is used in Indian construction sites is not up to the mark. So whereas in the US, they after seeing all the problems which Dhruvesh was mentioning, they had changed the type of grout to a new grout. And even today in India, we don't have a good quality grout. Even today. So this is a bigger concern, which we have to really look at because the voids is the problem. And if we have voids, the 100-year life of these kind of structures are really questionable. When I say questionable, I'm saying we will have to invest a lot of money on repair and rehabilitate these structures to reach a 100-year life. So thank you very much for organizing this topic, which is a rare topic. People don't take it, these topics don't come usually often. So thank you very much for bringing this topic onto the discussion in IAB. I think grout has to be given more importance, than, because it's really tendons are backbone of these structures. So we have to really grout them properly and protect the structures properly, which is not happening today. I'm openly telling this, it's an important issue. We are constructing left and right, but we are not grouting the structures in the right way it should be, because we don't even inspect them. That's another thing, like we need to change the way in which we work to enable inspection of the bridges before they start showing signs of distress. So that's something which is more, I would like to bring the discussion on. I can see Gopal Rai smiling on it. I think this is what we really have to change. We have to think about, because many engineers, if you think, they all talking about new construction, all new construction, but existing infrastructure and preserving them or conserving them, like Dr. Ashavardhan would agree with me, that word conservation is more important than all other terms which we use, repair, rehabilitation, retrofitting, all that. So I think that aspect, I think if we can promote more engineers to think about, conservation of structures in addition to building new one, I think that's something we should think. I will stop it there and then let everybody discuss, and then we can have a nice session.
Dr. Jyoti ma'am, I think she's there, or can you hear me, sir?
Yeah,
this grout thing which I mentioned, I can tell the story actually what we went through. We had 4 MTech students and we studied extensively different type of grouts which are available in Indian market. And we could not find even one grout which works and which is able to fill the tendon 100%. So if you ask me, I'm 100% sure that we have a lot of structures with a lot of void. We need to start doing something so that we can inspect them.
Professor, let me add to you, like as practicing contractor in rehabilitation and all, we should develop some instrument to check the, like inside how much percent the fill up, like UPV, or I don't know the exact path how we can identify, right. But we need to devise something which is on-site practical. Okay, otherwise, like it's like we only come to know how much grout is done through the bill of quantity of the contractor.
Yeah, okay. Which will be erroneous anyway. So
it will be always, as a contractor, I will always say I have done maximum. Okay, so as an engineer, we should develop now. A lot of optical sensors are available. We should think of this tendon with the sensors, and we should always check, because that decides whether this cable will stand for 100 years or not. That is only the only drawback is that tendons. If that is not done properly, we are challenging the part. Yeah. But let me thanks to first Dhruvesh Shah. I know him, Dhruvesh Shah, from last 10 years. बहुत बहुत बधाई Dhruvesh Shah साहब, बहुत बहुत congratulations. And after 9 years, really you have the correct path, and you are saving the national asset. When you are preventing and making the life of 100 years for which it is designed, and you are proposing some good technique, I think it is goes to the nation asset saving. So Dhruvesh Saji, आपको बहुत बहुत धन्यवाद.
Thank
Hello.
you, Balaji.
Yeah, Dhruvesh, I think your tagline is also we save structures. That is what is their tagline. So they are working in the corrosion process.
I have missed one slide. Like we internationally has one website which is called Concrete Preservation Alliance. We save structure. Everybody should visit to that site. It's free of cost site. It's not been any company oriented things. All the knowledge regarding the concrete preservations has been shared there. There are a group of people from worldwide different companies who are practicing. They are partners in that thing, and every second Wednesday of every month we keep such type of innovative products lecture. So every second Wednesday of every month you can go, there are events, you can go and log in, and you will get in 1 hour of PDS certificate also, who are making they're pursuing their PE also. So it can be wonderful. There is also an environmental calculator there which shows that if you are saving your this much square meter of concrete by repairing, how much beneficial it is to the environment. It's a wonderful site to go there. It's Concrete Preservation Alliance, or We Save Structure.
Right. Okay, now I would invite other panelists on our listening panels. First, I would like to, I'm having Dr. Harshavardhan Subbarao over here. Would you like to comment, sir?
Yes, thanks to Rish. Thanks for giving us this wonderful insight into the need actually of the hour. We have a huge stock of post-tension structures in India, and recently in the past 10 years at least, we've been starting to use external PT tendons also, apart from for retrofitting, of course, within main design in the initial construction itself. The point that arises is, can we not, the proactive approach and the instrumentation approach, these both have to figure in the tender document. The guidelines and the tender documents require to be developed on both these matters, for which we will seek your cooperation at the IRC. What we talked about today are detection and preventative technologies. Okay, this is after something has happened. When you see distress, when the need arises, then you go in, sort of thing. What we are talking about is a proactive approach in which this should not happen at all. This situation should not arise at all. So some of the things you showed us was the sacrificial anode, the flat anode, which is, I think, quite innovative. And the threshold values that you gave us of 5% moisture with or without the level of oxygen, like in the Peerbauer diagram, which you would have, but the PT tendon being different. And the fact that the Professor Radhakrishna raises a point which is very germane. He says that the proactive approach is simply not adopted in India. Forget about anything else. And the grouts themselves predispose you towards a situation where you will be having corrosion in any case. So the grouts in this country are not up to a standard which are usable, is what he says. Now, in such a situation, we have to take a preventative approach right at the start, because we know we're going to grout with a defective material. So if that is the case, apart from changing the technology of the grouts, say the 4 or 5 grouts that are manufactured, supplied, we also need to build in the technology upfront that the PT cable installer, it becomes incumbent on him to give a quality assurance certification at the end of his work that the grout is 100% there by the dry test that you suggested, by the moisture driving out test after the grout is hardened after a certain amount of time. And why can we not leave these probes, those probes you showed going into the grout for the dryer, why can they not be put into a tender document? And why can they not be permanently there and sealed so that at any future point in time, we can check the wetness or the moisture content along the cable and see what is the situation? Why can we not, between the interstitials that you show, the interstitials between the PT cables and the 7-wire strand, a single strand, that gap, that nano gap, that very small, microscopic gap, can we not pre-inject them upfront with what you showed rather than later, once you have to? Can this not be burnt into a tender document also? So a multi-barrier approach is, of course, the best. And you can at the one hand have electrically isolated tendons to know if there is any corrosion activity happening at any point in time in the life of the structure. This is simply not adopted in India. It is adopted all over Switzerland, all over France. Most PT structures are now category 4 type of protection, which is electrically isolated tendon. We can know when the corrosion activity starts. And if you have a Bragg sensor inside the cable, if along the entire length of the cable, you have a grating Bragg sensor, you can know where it is. You can pinpoint the location. So why don't we build in these technologies? I'm suggesting to all actually, since Radhakrishna said, raise the debate. So these are the technologies that need to be specified. It's not the damn use of the cable and the grout. It's also the detective methods that we need to put in. So at the top, at least for a limited region, we should be definitely having this drier situation that you showed at the top of a cable where the grout will settle. And we know that in a balanced cantilever type construction, the top hat cables like in Zuari anywhere, these are the ones which are the most prone. So why don't we in the future build this in? Grout is really our most defensive thing that we rely on. If the grout itself is useless, if the grout itself is not up to the standard and the moisture it traps is beyond 5%, we are predisposed to corrosion in any case. So this is the point I'm making. We need to not only do the technology of the cable in itself and all this and the grout, maybe modify the grout, but we need to build in the dry volume, the dry test, the driving out of moisture before commissioning the structure, at birth time. So as a birth certificate, these all issues have to be put in the tender document and in the need, and this has to be documented at that time, and the moisture content, everything, all this has to come into the birth certificate documentation at birth. This is my suggestion and my hope.
Yeah, I think this is really a call that rightly said that at the birth itself, everything should be documented and everything should be taken care of. Because once the corrosion is initiated, really we cannot stop that process. The only thing that we can do is we can just reduce the rate of that corrosion. That is what is said.
True.
So
true.
next time,
Jyoti, the true point is up to today, there is not one PT cable that is being constructed in India which has a Bragg grating sensor for its full length. There is not one.
Right. Now,
and why not?
Structural health,
why not?
Yes.
Simply because we don't want to change our tender document, or the client is ill knowledgeable about it, or doesn't want to change his mindset, or simply does not want to learn about the newer technology which will save us in millions and billions of rupees.
Sir,
in the structural health monitoring now we are having
the damn tender document to say, I will put in a Bragg grating sensor in some 6 or 7 cables, which I know will be the most sensitive to corrosion because of the profile of the cable and the grouting procedure we use. Why don't we build that as part of the tender requirement?
Yeah, Radhakrishnan sir, you want to speak something?
Yeah, I just want to say when we mentioned, when Dr. Harshavardhan mentioned about changing this tender document, that's about a sensor. Another thing, Dhruvesh also showed some photographs which others might remember now. There was a plastic cap or a metal cap which he showed at the end of the anchorage. You cannot find a cap like that in any Indian bridges. I haven't seen so far. I visited so many structures, but I could not see. If I'm wrong, somebody can correct me. But the same contractor building bridges outside India, they use that. And in one of the project, I even told them you have to put a plastic cap. And what they did is they found a waterproofing coating in Delhi Metro. If you can see that, they provided a waterproof coating, and which will not last for more than 1 year. It's out in the exterior environment. It will crack like anything within few months or few weeks actually. And you will have the cement inside will absorb the moisture. It is very, very bad situation for the strand at the anchorage. So we have to find this cap for the anchorage. And when I talk to the contractor, what they said is it is not in this schedule of rates. CPWD schedule of rates, it's not there. So they can't get a plastic cap. So these are probably where we have to work on these central documents which kind of govern all these things. I don't know how to how to change. Maybe the stalwarts here can say, Hegde sir, maybe you can come and please tell how to change these things.
Before Hegde sir, Dhruvesh would like to speak, I think. Yes, Dhruvesh, go ahead.
I would just like to take a
There's
minute.
a simple cap, which is not at all expensive when we talk about a bridge cost, but that's not available, and that is killing the whole structure.
Sir, I will just like to extend you two things, what Dr. Harshvardhan says and what Pillai sir says. It's a good gesture, good thought, Dr. Harshvardhan, that we can incorporate predictive measures in tender itself. Definitely it can be helpful. But the true thing is, we are living with thousands of bridges which are PT and other thousands of structures which are PT. Tendons, they have been used, and this is the I'm proud that this is my company. This is the first thing available in the world to do this thing for protection of the by using impregnation method. Second thing, back in 2018, I could visit one bridge in Porbandar in Gujarat, wherein the chief engineer of the state says that we can see the cracks in the soffit of the bridge, and please do something. So we went there, we inspected, we did carry it out, and we given them the pilot project proposal to check the voids and then carry out moisture test and then do impregnation. And by the time, because of the bureaucracy, the tender comes out for the small job, and when we come to know, the bridge collapsed. So sad. I have not shown all that photographs. I had lot of things I can talk for like 8 hours on PT things. I had that much.
No, but the point, Dhruvesh, is that in this case, crack started and then only he asked you to do something.
Exactly. If you can do something,
we have to actually start doing before the crack comes.
Yes. So there's a reactive, the predictive approach should be there in case of new construction, and tender has to be gone through back, and we need to have a quality check. Definitely it can be helpful after 20 years that nothing happens. But we have to take care of the existing structure also, which can be easily done by the innovative things.
Tell me something, Dhruvesh. Are these patented technologies, or are they technologies which are now broad spectrum and usable?
PT impregnation is a patented, because it has been innovated by David Whitmore, whom I had shown in various photographs. PTI impregnation is patented. Evaluation and other things are not patented.
Right.
Yeah, Dr. Surya Prakash, would you like to comment something?
Well, actually, I just joined late, and I just wanted to be part of the discussion and learn. And I've listened to Engineer Dhruvesh Shah previously. I think, PT cable, we do a lot of pre-stressing, and it is very important. And fiber brack grating, as correctly told by Dr. Harshavardhan, I think, it doesn't cost much. Unfortunately, we have to change the mindset, and, it's not even like 0.5% of the cost of the, So you can in fact install it and then check. Long-term monitoring is a very, very important thing. The kind of number of bridges that what we have in India, and it is very essential. And I'm sorry I joined late because we had another webinar going on at our IITH. Anyway, so I just enjoying the discussion, and I know we have a lot of things to do, and especially the CPWD tender specification. I completely agree with Dr. Radhakrishna. I think that's one of those things. I think we have all the stalwarts of bridge community here. If we can, make an effort and change these small things, I think, that we will save, I think, millions of rupees of, our tax payers from, common people, like, so that we have to really work hard on that. Yeah. So with that, I think, thank you.
Thank you, sir. Hegde sir, are you there? We would like to hear from you also.
I'm there.
Yes, sir.
Yes,
sure.
I've got a little bit different view. Thank you very much, Dhruvesh, for your excellent presentation. It was an eye-opener, especially as Dr. Harshavardhan said, for the detection as well as how to take care of after the corrosion has been initiated. Now, as far as the grouting is concerned, it is not that there is not a procedures or the manual or the monograms are not available for the proper grouting. Even the latest IRC 112, I was just checking over here, which we have brought out, we have emphasized quite a lot on the grouting. There is a section on the grouting itself, and also the quality assurance, quality workmanship, how we have to carry it out. The problem is as soon as the post tensioning is done at the sites, all the people are in a hurry to, do the grouting. The grouting is done in a hurry.
Exactly.
See, it is not the question of absence of the guidelines which is available. If the grouting is not done properly at the site, then the problem will be there. It's not whether it is even internationally, if you followed whatever the procedure which has been followed internationally, the grouting procedure is our procedures which has been prescribed in the courts also is of the same standards. It is not. It is not in any way lesser or compared to those standards. But how it is to be implemented at site, how it is ensured that the proper grouting is ensured to be implemented at the site, that is the issue here, basically, in my opinion. Of course, what Dr. Harshavardhan Subbarao said also, once the grouting is there, as he rightly said, at that particular point of time itself, if you can specify some of the measures to inspect or test whether the grouting has been done properly or not immediately, and certify that the grouting has been done properly by using some of the technologies which has been expressed by Dhruvesh Shah, whether it's a moisture content or whether it's a segregation has taken place or bleeding has taken place, at that point of the hardening of the grout, we can just make sure whether it is happening or not. That methodologies can be specified in the contract specification, as everybody is said. That can be done. Irrespective of that, it's very essential for us to devise the ways and means to detect the initiation of corrosion. After all being done, also there's a possibility that the corrosion sets in later. It's very important for us to have a maintenance methodology prescribed, and after the work is done and the proper maintenance is done to the bridges, and also it is monitored for the corrosion, whether the corrosion is taking place or not. It's not just the grout is not done properly. The corrosion can take place because so many other things also. What happens is during the concrete, after the concreting is done, sometimes the vibration has to be done. During the vibration, that the duct might have been punctured. So many possibilities are there. That needs to be ensured. So in my opinion, it's a question of the implementation. It's not the question of the absence of the guidelines which is available with us. The executing agencies, whether it's a contractor, whether it's other agencies, that has to be, we have to make sure that it has been executed properly. That is what I was. There are sufficient guidelines available in the form of monograms, in the form of the codal specifications, even the ministry guidelines, MRTH Orange Book, what I call it as, also they give how to carry out the specifications. Maybe after the grouting is done, whether the grouting is done properly or not, the detection in the form of what is the moisture content, what I saw is 0.3% to 0.7, it should be less than that or something like that. Whether after the hardening, that the segregation has taken place, the settlement of the cement within the cement grout at the bottom has taken place, the top grout is not proper. These are the sort of detection has to be done at the initial stages. That's what I feel. Nevertheless, Dhruvesh, it was an excellent presentation. I really enjoyed it, and it was quite informative too. Thank you very much.
Yeah, having all said, really with the advancement in the technology of our structural health monitoring, it is really a pity that in India, we are not so much executing those particular techniques over here. And I think it's a high time now that we start doing these things. I think now we'll take up the questions that have been posted by the participants. Dhruvesh,
Yeah.
I think even you will be able to see the question answers.
Yes.
The questions that have been posted. I'll just go one by one.
Okay. What are the chances of?
Yeah, I will read it for you.
Fine.
I will read it for you, Dhruvesh.
Yeah. Please.
Yeah, what are the chances of construction error during pre-stressing and how to deal with it? If possible, please explain with an example. I think it has not to do with the corrosion, but yeah, you can go ahead with answering this.
I will talk mainly about the grouting things of the tendons. I'm not an structural engineer who can talk for the pre-stressing methodology, or I'm not a pre-stressing expert, frankly speaking. I think Jyoti can explain more better than me in that case. But the grouting, what Sir has says immediately that we had a lot of documentation and standards in the tender itself. And if somebody can take care of grout as important as laying a PT strand at the line and tensioning that, if the same importance has been given to grout, it will not happen any error.
Okay, good. The another question is that from Parmar Ruchit, he has asked, can you please give a highlight on availability and reliability of analytical methods which can be used to know the exact strength of corroded strand at that particular location? So if your strand is corroded, what is the exact strength now remaining? That is what he's asking.
Oh, frankly speaking, it's not, I cannot give that thing. The only thing is that if you know the location where strand is grouting, you can measure the section of the strands and then you can correlate it with your design.
Can I say something here?
Yeah.
Yeah. About the, see, one thing I would like to say is that the strand corrosion is not like a typical steel rebar corrosion. So usually in case of a rebar, we can look at the cross-sectional loss and probably determine how much is the, because the bulk material property is still going to be same. So the strength in terms of per unit area, you can still have same properties like modulus, etc. will not change. But in case of strand or especially pre-stressed strand, when you have corrosion, it is stress corrosion cracking or hydrogen embrittlement. This kind of phenomena also is there. So which actually affects the bulk property of the material. So the residual cross-sectional area is not something which you should look at.
Oh.
In case of pre-stressed strand. In case of normal steel rebar, you can look at residual cross-sectional area and still you can calculate the strength of the element, etc. But not in case of pre-stressing strand, because there you may not have any cross-sectional loss, but you'll have bulk material property, like it will change because of stress corrosion cracking and hydrogen embrittlement. So it's a completely different animal altogether, the pre-stressing strand and steel rebars. So this is important to consider because usually we go by residual area and then calculate the remaining load carrying capacity and all that, but we can't do that for strands.
Right. The next question is from Yogesh Naik. He's asking that in dry air method, which you had shown in your presentation, how do we come to know the exact location of corrosive portion of PT tendon?
Dry air method is used for measuring, knowing the moisture content. It doesn't tell you anything about the corrosion or exact location of the corrosion. Normally, corrosion will happen in a strand. With our experience since almost a decade, we are doing. I had been in 2011. I had been in Toronto for one of the parking garage measurement. We found that if there is a void, then only you find the corrosion of the rebar. Number one, if there is a void and moisture. Now, first of all, we want to remove the moisture or we want to check whether moisture is there or not. And to know the void, we need to go for the either impact echo or other method what I had shown.
There is another question from Yogini Deshpande. She is asking, can we use coloring methodology to protect tendons from the corrosion? So,
come again, please.
Maybe epoxy coating or something she's talking about. Means just as we do for the rebars, we paint it. So can we use the same methodology for the tendons also to protect it from the corrosion?
It's an opening of a different Pandora box. Epoxy coating, maybe fusion bonded epoxy for the strands. I don't know how effective it can be and how it can be treated and when you stress it, and I don't think so. We even had a lot of issues with the epoxy bonded reinforcement, and we don't want to go into issues with the. It's a good system. I don't say technology is bad. Technology is excellent, but if it can use it rightly, good for the reinforcement. But for the tendons, I don't think.
Yeah. And if your tendons are now completely corroded, how they can be replaced? That is a question asked by Kumbar Santosh. How can a replaced corroded? How can we replace corroded tendons? That is what you're asking.
PT contractor can easily do that. They know how to do it. They can,
Yeah, yes.
they can extract it and they can do it, change the strength.
Yeah, those can be easily removed and replaced.
Not easily, but yes, they can do.
Yeah.
It's not easily, for sure.
Nobody does it, sir, in India.
Or they can
Nobody
be
in India
just
does
kept
it.
as an extra tendons, that is external pre-stressing can be done later on
Yeah.
to
There are other ways.
compensate the loss for that.
Guy does a lot of things about that. He know how external PT, how externally CFRP can be used, and it can be post-tension, and he is the expert in that thing.
Right. Then Omkar Kumbhar is there. He's asking which are the critical locations in PT girder which shall be inspected by opening only, that is during the audit. So you have showed some slides where you have shown that you have opened up the and you have shown the corroded this thing tendons. So what are those critical locations where you need to open up and look into the exact aspect of corrosion?
Yes, good question. Normally, if you see the profile of a tendon, wherever you will find that there is a it is a sagging condition, then the top of the sheet will be have a more sort of void or more sort of segregation or voids where we need to, or where the water will accumulate. And similarly at the bottom portion, at the when it is on the hogging portion, so it depends upon how the profile of the tendon is there, and we can know by simple this thing that where the grout could be a void, or it can be a segregated or wet grout or something, and that is the location which are more susceptible to corrosion, and that we can identify. But obviously we can use the impact echo test and we can use different method, but if you want to simply open it up, you can select that location.
I think we have a nomogram of IIB and that will give you all this. It is based on the old TR44 report of Concrete Society, and I'm sure we have a nomogram on that on pre-stressing.
Yeah, that's what one question by Karthik has been asked. Is there any nomogram coming up? And that is specifically addressed to Radhakrishnan sir. That is there any nomogram coming up from Dr. Radhakrishnan for pre-stress concrete, just like reinforced concrete as explained in maintenance and repair of concrete structures and references NPTEL lectures? Radhakrishnan sir, you can just address to this.
Nomogram, the same nomogram which is in that can also be adapted to check the life of pre-tension, not for post-tension. For pre-tension structures, we can use that, but not for post-tension structures. But the input parameters have to be different when we use the same nomogram.
Okay.
Ma'am, I have a question, if I can.
Yes, sure. You can also ask. Being in panelist.
It's to the Dr. Harshavardhan or the senior designers here. Sir, in India, I have seen most of the post-tension structures, they use internal tendons, grouted but internal. So if you look at what Dhruvesh has presented, most of the inspection is done on external tendons. And in India, we don't have, most of our structures are internal tendons. How do we go about inspecting them? Because it's very, very difficult to inspect the internal tendons. Why we are actually adopting only internal tendon structures? In most of the metro we have like that. Why is it so? What is the design or the reason behind adopting that feature?
It's simple, sir. Earlier the codes did not allow for external PT cables at all. So it's only in recent times that we've got that allowed in the code, Indian code. Secondly, there are, like, for example, Kanakadurga flyover in Vijayawada, elevated road, has a mix of both external and internal PT cables.
Okay.
And actually the design gets a little more complicated because if you're using a software like Midas, it lends you into lots of modeling difficulties. You know, for a designer, it becomes more complicated to have a mix
external or internal?
When you have a mix of both.
Mix of both, okay.
Okay. So usually the nature of using external PT tendons, the corrosion requirement, corrosion protection has to be very, very good, because you don't get the blanket of a cover concrete and a cable and a grout, and all that defensive barriers are lost. Okay, but you can do things like drying out the inside of a box, dehumidifying a box, which is expensive, and we don't do it in India. But it's done elsewhere on large crossings, especially marine crossings. We deal, for example, Great Belt crossing built 30 years ago is fully dehumidified. It's fully dehumidified the whole length, its whole box. So these kind of things are technologies which are expensive. And the mindset of our people to get that guaranteed 100-year design life, that word guarantee does not exist in the dictionary of the makers of, but this is the main problem we face. And what Venkat said, Hegde said about I wouldn't call it negligence. I'll talk it that chalta hai attitude, you know, that workmanship failure attitude, that quality of workmanship to be ensured that grouting is fundamentally the most important thing for the durability of the entire structure as a whole. And if that durability is lost, the strength will go, you know, at some point. That mental gearing is simply not there. So yes, I again reiterate what I said earlier and what Venkat also endorsed is that at the time of the birth certificate, we have to have quantifying methods to know what is the moisture, to know what's the sort of the voids ratio, that the percentage of voids along the entire length that may be. And if we can at least instrument some of the cables with Bragg sensors, at least. If not, adopt electrically isolated tendons, which are nearly twice as expensive as normal tendons, twice to more sometimes, depending upon the size. Adopt electrically isolated tendons, which are there in the FIB code for the past 15, 20 years. The Swiss have been using them for more than 25 years, electrically isolated technology for the tendon. So why don't we do that? If not anything else, you don't want to do anything, at least you electrically isolate the tendon, and then you will know when the corrosion, you will know when there is an issue coming up. So these are some of the things we have to change the way we work. The use of external PT cables, traditionally, it has been avoided because one is the fear of this corrosion issue. And the other is also you don't get the levels of eccentricity that you want. You know, you don't get it to bond with the if you have bond with the box, and the stresses that you have, the stresses and strains, then are totally different. The strain in an external cable and the strain in the concrete adjacent to it, because they're not bonded, are totally different animals. So the stress and strains between the two systems are totally different. And these are the reasons that, you know, people are pessimistic about adopting it. But now, as I told you, we have done one very long flyover in Vijayawada that I know of. There must be many others where we have used either or mixed of both. But repair rehabilitation, external. There's no question. External cables for all repair rehabilitation of bridges is the only way to go.
Yeah, I think just adding on to what Dr. Ashodhan is saying, I think just that you get more out of that internal tendons. Strain compatibility is there all along. So you get more out of the internal tendons, and also a possibility of failure in external tendons, vandalism, and so on. So there's always that fear factor is there. So I think those are the main reasons. But if we can ensure, and I like what you said, I think the eccentricity also, unless the situation demands, you know, it is advantageous to go for external tendon, then, you know, it's always better to go for the internal tendons.
Yeah,
coming to the scanning, I just wanted to add, the GPR is the only thing that I can think of. But again, it's costly, you know, you have to literally scan.
But in marine conditions, the GPR is too sensitive to salt. I've seen it fail on Zuaria. So
I see.
Maybe now the technologies have changed, but when you have salt spray, the GPR is highly erratic. I don't know now how much the technology has changed with a lot of time, and so much improvements in technology.
Not only that, in case of strands, you have these strands going in different convoluted fashion. It's not a very straight line thing. So it will give you lot more irregular data, which will scratch our head on getting something out of it.
Now the resolutions have improved. I think compared to what it was 10 years ago, I think now the resolution capacity has increased. In fact, you can cut through.
Maybe we should get a structure to do this. Yeah. That's what we have to do. Find an old structure. Maybe somewhere from, I don't know from where to start, but we have to get a structure to do these things, and that will probably, have a snowball effect on everybody start, I also want to do. Somewhere we have to start off, find an old structure, PT structure, and then start inspecting and bring out the
First PT
issues.
structure has been built in 40s, so we'll not find such a old structure right now.
Now we can
That
take
is
a
also
Bandra-Worli ceiling.
Sir, I have
no.
I have come across.
See, you're saying no, that's a problem. We need to take.
Yeah.
Sir, I have come across a structure.
Sometimes we feel it's better not to know the reality, truth or something, no? But
sir, I come across a structure which is 8-year-old and PT strands has started breaking. It's not a bridge structure, but it's a building structure. And hopefully, if everything goes right, then maybe a few weeks of time I will be doing all this test at the structure. I'm not sure, keeping finger crossed. If I'm really going to do that thing, definitely I will invite all of you so that you can have a handful of experience for the structure.
Yeah, Dr. Pillai.
Right.
Dr. Pillai, yeah, that is coming back to your externally pre-stressed cables in the post-tension girders. In fact, I have been trying to advocate from the principle of what you said just now. It's very easily inspectable, the externally pre-stressed cable for a long time. But unfortunately, you know, like what happened was what Harshavardhan explained, that the people's perception was that the multi-layered protection system against the corrosion is not available. But that is just a psychological perception.
yeah.
Why I'm telling you is, even when we have done the first externally pre-stressed cable, externally pre-stressed post-tension was done in Sringeri Mutt. First bridge which was done by using the external pre-stressing over there. By that time, Dr. Harshavardhan's father was in charge of that bridge. I still remember that. And his assistant, Mr. Haridas was the designer for that. That was the first externally pre-stressed cable, pre-stressed post-tension bridge. Later, we used it in Delhi Noida bridge. That was done in 2000, perhaps. You know, so externally pre-stressed post-tension girder bridges are much, you know, like from the inspection point of view, is much better. Even multi-layered protection is similar to that of the internal tendons. Why I'm telling you is, there also it is grouted. We have got a duct over there, sheathing duct over there, high duty sheathing duct over there. But it was just some sort of a psychological sort of a feeling that the multi-layer protection was not there. That is why somehow it was not approved of in our codal things, you know, that is why. But ironically, you just see the similar situation was there in Europe also. Once upon a time, to overcome this problem, the Mathivet, what did he do is, he took out the cables from the girder and took it out at the top of the cantilever bridge, say for example. Then he called it an extra dose cables, you know, and he didn't want to use this. He called it an extra dose cables, but that is nothing but an external cables, externally pre-stressed cables. He used it. That is how the invention of the extra dose cables also took place.
Okay.
There, you know, what happened was, I think for the cable stay bridge, the permissible guts was 0.45 UTS always, guts guaranteed ultimate tensile strength. So the number of cables, if we had gone for a cable stay bridge, was increasing. But by going for the externally pre-stressed cable, he could have gone up to the 0.8 or 0.75 UTS. And he said, I'm going to use the external, you know, similar to that of the internal stressing, I'm going for the external pre-stressed cables. I'm not going for a cable stay, you know, stay cable system. I'm going for the external. He stressed
so cost of steel is going to be less.
He stressed the cable up to 0.75. And not only that, the eccentricity also increased. He took it out of the section. That the eccentricity, increasing the eccentricity, it gave the, you know, neutralization of the moment to a large extent, you know, because of the eccentric cable which is taken up. That is how the invention of the extra dose cable took place. That's how it is.
Sir, a one-page article on these things would be very good.
No. Many people have written on that. That I've just.
Now these, you know, the hidden stories behind various things. It will be nice.
But it's back again. Dr. Pillai, the external cables, externally pre-stressed cables are going to be very popular again.
Okay. Because it's easy to inspect, maybe the main reason.
Absolutely, yes.
Yes. But one thing I want to add, since Venkat is here, he's moderating a course which will be conducted as of next month and they will distribute. I think it's iStructi or which one? Venkat, what fora? iStructi fora.
Yes.
So I invite all who are involved with pre-stressing. It's a course which we're doing, dealing with pre-stressing in all kinds of structures, with a more emphasis on metro, bridge, building, and some special structures like aqueducts and things like that. So it's a broad spectrum shot at pre-stressing over every Saturday, I think 3 hours or 4 hours, I think 10 lectures or 12 lectures, something. Venkat has, and us in the ISTRUCT, I think, have put that course together. It'd be very useful if people want to join. Grouting will be one of these, and I hope we can get Vector to come and sponsor that, Durvesh, if you're listening, because then your message will really go out to those who are dealing with this stuff.
Yes.
If you're keen to speak to Venkat, you might be able to take a sponsorship position on that and show us how to deal with all this. After all, these are important technologies which are simply not being adopted broad scale in India. That's I just want to add. Venkat has been quiet, so I thought I should make that true. This course is there, and it will be very.
The details will be available on that website of iStudy,
I think
right?
you can. Yes, you can join, and we'll see to it with distribute.
I will be requesting you to.
Yeah, it should be distributed well.
Yeah.
I will be doing it to you.
Yeah, Dhruvesh, I think we'll go to the last 1 or 2 questions. We are now running out of time now. The last question that is asked by Omkar Kumbar is asking whether can we adopt self-sacrificial anode in grouted duct to prevent or slow down the tendon corrosion as a general solution? I think that is...
No, we can, there is a catch. We can use the sacrificial anode in a grouted duct with a condition that the grout tandem is completely grouted, because the ionic movement between the anode and the strand can only happen if there is electrolyte. If there is a void, it will not work, number one. And number two, the gap is so small that we need to develop a special anode designed accordingly, and it can be done. I had shown few slides where there was a void, it can be done and then posted later on, like filled with the grouted.
Yeah, and one last question from, I think it must be from a student. And I think Radhakrishnan sir would be addressing that, because his question is related with, are there any sponsorship or scholarships available if we want to do research in this particular topic of corrosion? Pillai sir, can you throw some light on this?
Are there any scholarships?
Sponsorship, yeah, sponsorships available if he wants to have to do some research in this corrosion topic for PhD work.
We have, like regular GATE or regular PhD, scholarships. All the PhD students are, funded students by Ministry of Education. So there is no special scholarship for corrosion as such. I mean, I don't know about that. But definitely this is a topic of interest, at least to me, and I have a good group here. So if you are interested, you can definitely reach out to me and we can discuss further.
I think Dr. Busari should answer that, because she has got a lot of scholarships earlier, I say.
No, that is actually a point to make. We are in the private institutions. Generally, we don't have such scholarships. Scholarships and sponsorship, they all goes to IITs. Okay, then we are through all the questions. Dhruvesh, I once again thank you for giving such a presentation, and we had, I think, a nice panel discussion also. Radhakrishnan sir, personally, I thank you. And now I hand over the proceedings to Deepika Singh, I think, to the coordinator, Deepika. Yeah.
Thank you, Jyoti. Thank you for all this arrangement.
Deepika, I think you are muted. Your voice is not...
I had purposely kept my presentation 10 minutes less so that we can have a good panel discussion, because that's the main thing we can discuss. I could have make it a little bit slow and extend it to 1 hour completely, but I had restrict it to 45-15 minutes so that we can have a good question answers and panel discussion.
All right. Yeah, over to you, Deepika. Now,
is it audible now from my end?
Yes, it's audible.
Thank you very much, ma'am. So I'll begin the vote of thanks for today's lecture series. So to all the honorable dignitaries, it's my privilege to have been asked to propose a vote of thanks for our special lecture today. I, on behalf of IIB, extend a very hearty vote of thanks to all the members and non-members for gracing us with your presence and Sorry, just give me a minute. I, on behalf of IIB, extend a very hearty vote of thanks to all the members and non-members for gracing us with your presence and sharing with us your valuable feedback and suggestions. Firstly, I would like to thank our Director General Engineer DG Divte for always providing us with a vision for the future of IIBE. Our President Engineer Vinay Gupta for constantly guiding, motivating, and inspiring us to achieve the vision. I would like to thank our treasurer, Mr. P.R. Kilker, for being a strong support of IIBE. I would also like to thank our honorary secretary, Engineer Swapnil Joshi, for always managing this platform. I would like to thank our honorary secretary, Dr. Gopal Rai, for always guiding us with his humorous side. I would like to thank for our today's speaker, Engineer Dhruvesh Shah, for his enlightening and entertaining presentation and for sharing his valuable opinion in this platform. I would like to thank our today's moderator, Dr. Jyoti Busari, for managing the webinar on this forum. I would like to thank our today's panelist, Dr. Radhakrishna Pillai, for the support towards this webinar. I would like to thank all our eminent executive committee members for their valuable presence and support. And also, I would like to thank Ruhi Agarwal, who's the coordinator of IIB, for always helping and managing all the events of IIB. Last but not the least, Mr. Josefa for all his IT support. And last, I would like to thanks to all the participants for always coming in huge numbers to make this webinar a success. Thank you, everyone.
Thank you.
Thank you,
Thank you,
Deepika.
Deepika. Thank you, everyone. So I think we can officially declare that this is formally now it is we are closing the session for today. So thank you very much, everyone, for your great support.
Thank you, Swapnil.
Thanks for a
Thank you.
wonderful
Thank you.
event.
Have a good
Thank you,
day.
everyone.
Thanks, Dhruvesh. Thanks,
Dr.
Thanks.
Ashwadan. Thank you, Dr.
Radhakrishna.
Pillai.
Thank you, Radhakrishnan
Thank
sir,
you.
once again.
Thank you.
Thank you.
Thank you.